Oh, hello. Yeah, in this video, I want to continue to talk about causal analysis using R, and the topic is the weak instrument test. So this is related to the instrumental variable analysis. For our first video on instrumental variable analysis, we talked about it's very critical to uh, make sure the instrument variable is strong. Okay. What strong means is it's really correlated with the exogenous variables. Okay. And actually, there are statistical tests available for testing that, and there are actually multiple tests, and also there are multiple R packages for implementation. But in this video, we'll keep things simple, where we will just use the AER package to perform the weak instrument test. Okay. And of course, I mean, to really select an instrument variable, you need to combine statistical tests with the content knowledge, okay, the subjective knowledge. Okay. So it's not a very easy process. Okay. You need to spend a lot of effort on it. Okay. All right. So I'll show you here. So let's load the library AER and the library CAR, which is another package for linear regression. And we can set random seed, sample size 500. We generate two exogenous variables, x1, x2. From standard normal distribution, we generate two instruments, z1 and z2, also from standard normal distribution. Then we generate two endogenous regressors correlated with the instrument plus noise. So you can see here the n-dog1, n-dog2, they all depend on z1, z2. And n-dog1 depends on x1, n-dog2 depends on x2, and plus some errors of some noise. Okay. And then the outcome variable dependent on an endogenous regressors plus exogenous variables and the noise. Okay. All right. So this is actually the true data generating process. And then we put everything together into a data frame. This is what the data looked like. And to perform the IV regression, the instrument variable regression with two endogenous regressors and two instruments, we use the formula dependent regressed on exogenous plus endogenous, condition on endogenous plus instruments. So that is the syntax. Okay. So you can see we specify this formula y tilde x1 plus x2 plus n-dog1 plus n-dog2 given x1 plus x2 plus z1 plus z2. Okay, so we have x1 plus x2 in both the model statement and the conditional statement. So we put that formula into IV underscore formula, and now we can fit the IV reg, use the IV reg function, use the formula applied to the data equal to data. We get the IV model. Okay. And then we can summary with diagnostics, including the weak instrument test. Okay. They are actually the first stage F statistic. Okay. So summary, IV underscore model, diagnostic equal to true. We have to specify diagnostic equal to true. So this is what it look like. The output look like. So here you can see the function called the residuals, which are not very large. And now you look at the coefficient table, the estimate column. For n-dog1 and n-dog2, you can see those estimates are the effects of the x1, x2 on n-dog1 and n-dog2 after accounting for the instruments. Okay, so for n-dog1, that effect is positive. For n-dog2, then that effect is negative. But both effects are highly significant statistically. Okay, and we are more interested in this diagnostic test. So you see the weak instrument N-dog 1 and a weak instrument, N-dog 2. Okay, you get degree of freedom 2, and then you got Wu-Hausmann test, you had the Sargent test. Okay, so the weak instrument N-dog 1, weak instrument N-dog 2, these are the what we call the weak instrument test. Okay, the null hypothesis for that is the IV is not correlated with the endogenous variable. Okay, so basically, if we accept the null, then it's a weak instrument. But here, the p-value is very, very, very small. So we have to reject that null. And so these IV we used in the model are highly correlated with the endogenous variable. So they are good instruments. Okay. And the Wu-Hausmann test, the null hypothesis is that the endogenous variables are actually exogenous. What that means is, so we assume they are endogenous, but actually, whether you're adjusting for instrument variable or not, it doesn't lead to much difference. Okay, so actually we don't have to adjust for instrument variables. So that's what say endogenous variables actually exogenous. So for this data set, the p-value from a Wu-Hausmann test is 0.56. So we accept that null hypothesis. So actually for this data set, adjusting for instrument variable is not necessary. But if we did that in this way, the two instrument variable we selected are highly significant. Okay. So it's kind of a little bit seemingly contradictory, but they're not. Okay, so because the weak instrument test and the Wu-Hausmann test, they're testing different null hypotheses. For the Sargent test, it is only for over-identified models, which means you have more number of instruments than the number of endogenous variables. So that means in our case, we have two instrument variables and two endogenous variables, so they're just identified. So this Sargent test does not apply for this situation. That's why you see NA for its outputs. Okay. Of course, you can look at others, like the R square is pretty good. So saying this model fits the data pretty well. So we can kind of trust the hypothesis test results. Okay, and yeah, this is like a straightforward example showing you the weak instrument test. And again, with real world data sets, selecting a good instrument variable is not very simple. You have to do very careful work to combine statistical tests and also domain knowledge and some other deep thinking, I think. All right, thank you for watching, and if you like this video, please subscribe to our channel, recommend the video to other users, and also click on the notification bell. I'll see you next time.